So discussing. So for the reaction N2O5 gas giving 2NO2 gas and half O2 gas, the disappearance rate is 6.25 into 10 power minus 3 mole per liter per second. So what will be the rate of appearance of NO2 and O2? This is the question asked. So you first write the rate expression like this. So this rate is 6.625 into 10 power minus 3. So what about this? So this will be dNO2 dt is equal to so this is 2 times 6.25 into 10 power minus 3, which is equal to 1.25 into 10 power minus 2. Mole per liter per second. So this will be dO2 by dt is equal to 1 by 2 into this value. So that is equal to 3.125 into 10 power minus 3 mole per liter per second. This is simply cross multiplying and simplification. Only thing is you should know to write the rate expression properly, and then you have to substitute the values and find out the answer. Is it clear? Jimana Begum. You have typed no, sir. What is your problem? What you are not able to understand? You please put it in the chat box. Oh, board is not clear. Is it clear now? F. Okay. Now in the reaction, Br O3 minus aqueous 5 Br minus aqueous plus 6H plus aqueous giving bromine liquid and water liquid. Now you find out the relation between, see, the question is like this: find out the relation between the rate of disappearance of bromine, rate of appearance of bromine, rate of appearance of bromine, and the rate of disappearance of bromide ion. Rate of disappearance of bromide ion. Again, in the options, 4 different relations are given, and you have to choose the correct one, but you try to find out the relation between the rate of disappearance of bromide ion and the rate of appearance of bromine molecule. Again, you write the rate expression. It is minus d BrO3 minus divided by dt is equal to minus 1 by 5 d of Br minus by dt, which is equal to 1 by 3 d of Br2 by dt. So what is the relation? We are going to relate this and this. As it is only a rate comparison, see, minus d Br minus by dt is equal to, this 5 will go over there. So 5 by 3 d Br2 by dt. So answers may be like this, or this minus sign can be put over here, or this 3 by 5 can be put over here. See, it will be only the interchange of sign and the numbers. But this is the general expression. Options may contain many things by simply the interchanges of sign and the numbers. Say, for example, this may be given as a correct answer, or this can be given as a correct answer. Minus 5 by 3 d Br2 by dt. Question may be, answer may be given like this, or answer may be given like this also. d Br2 by dt is equal to minus 3 by 5 dBr minus by dt. All are correct answers. Or minus can be put over here. It is only mere a play of a number and the signs. Clear? So the next problem. At a constant temperature, a graph is given. This is x coordinate having the factor x. Y coordinate is having the factor y. And this is a straight line. Question is, what are x and y? What are x and y? When the order of the reaction is 0, and when the order of the reaction is 1. When order of the reaction is 0, x is the concentration of reactants and y is rate. Because for 0 order reactions, rate is independent of concentration. That is why there is no change in the rate. When it is a first order reaction, X is a concentration where Y is half-life, because half-life of a first order reaction is independent of a concentration. See, the idea behind this particular graph can be asked in various ways. For first order reaction, the T half is independent of the initial concentration. And for zero order reactions, the rate is independent of concentration. Whatever may be the concentration, the reaction will take place at a constant rate for zero order reactions, because the zero order reactions rate can be altered only by the use of the catalysts. So this is an important understanding you should have. Next. The half-life for a zero order reaction. See, the order of the reaction is a zero. What is the order of the reaction? It is the sum of the power terms that involve in the rate determining step. It is a zero order reaction. The initial concentration is a 0.02 molar. The half-life for a zero order reaction having 0.02 molar initial concentration of reactant in 100 seconds. It is 100 seconds. Half-life is 100 seconds. Find out the rate constant. Rate constant is asked. You have to find out the rate constant. Three important information are given. Number one, the order is 0. Number two, the initial concentration is 0.02 molar. And number three, the half-life is 100 seconds. See, for zero order reaction, K, the rate constant is equal to 1 by T A0 minus A, which is A0 is the initial concentration and A is the concentration remaining at the time T. So what is given is half-life. So time is equal to 1 by K, time goes there, K comes here. As this is T half, this has to be A0, and what is remaining after T half is A by 2 or A0 by 2. So 1 minus half, this is equal to T half, 1 by K, A0 by 2. Because in A0 by 2 is subtracted. What is remaining is A0 by 2. So T half is equal to A0 by 2K. Or I can write K is equal to A0 by 2T half. So A0 is a 0.02 molar divided by 2 times T half is 100 seconds. So this becomes, this will go off. It is 0.01 by 100. So 2 more points. The point has to be shifted. It is 0.0001 mole power 1 minus 0 liter power 0 minus 1 per second. So it is 1 into 10 power minus 4 mole per liter per second. So this is the rate constant for this reaction. The unit for rate constant is very important. The general expression for the rate constant unit is mole power 1 minus n liter power n minus 1 per time. In the place of n, You put the order of the reaction. Suppose if it is a zero order reaction, mole power 1 minus 0, liter power 0 minus 1 per second. So this is equal to mole per liter per second. If it is a first order reaction, mole power 1 minus 1, liter power 1 minus 1 per second. So mole and liter will vanish. You are getting per second. If it is a second order reaction, mole power 1 minus 2, liter power 2 minus 1 per second. So your unit will be liter per mole per second. So this general idea you should have. So whatever may be the rate given, you can write the unit for the rate constant. Clear? Thirteenth problem. The rate constant for a first order reaction. Order is first. The rate constant for a first order reaction is 4.606 into 10 power minus 3 per second. The time required to reduce 2.0 gram of the reactant to 0.2 gram. So I am having a reactant in a reaction chamber. It is 2 gram weight and it has to become 0.2 gram. What will be the time needed for this conversion when the reaction is a first order and the rate constant is this? This is the question asked. This is the question asked. First, you write the rate expression for the first order. K is equal to 2.303 by T log A0 by A. This A0 by A can also be written as A by A minus X, which means X is the amount reacted at time T. So A minus X is the quantity of the reactant remaining after time T. So you should not get confused here. X is the quantity of the reactants reacted in time T. Therefore, A minus X is the substance remaining after time T. So when you substitute properly, so T can be brought over here. It is 2.303 by K log of A0 is 2 gram. It is reduced to 2. It is reduced to 2 means what is remaining is 0.2 gram. What is remaining is 0.2 gram. So you can substitute the value of K here. It is 4.606 into 10 power minus 3. So this is 2.303 divided by 4.606 into 10 power 3, because minus 3 can be 10 power 3 into log. It is 20 by 2. So 2 times. So this is 10. So log 10 is 1. So this becomes exactly the double value. So it is 1 by 2 into 10 power 3. So 1 by 2 into 10 power 3 means it is 1 by 2 into 1000. So in 500 second, the 2 gram reactant will become 0.2 gram reactant. Clear? Next problem. If the rate constant of a first order reaction is K, it is a first order reaction, and the rate constant is K. Rate constant is K. What is the time required for 99% completion of the reaction? What is the time required for 99% completion? 99% completion means it is only 1% reactant is remaining after time t. Again, you write the rate expression. K is equal to 2.303 divided by T log of initial concentration is 100 and the concentration remaining is 1. How this 1 comes? This is A, this is A minus X. A is 100, A minus X is 99% complete. Therefore, what it is 1. So, normally the confusion used to come here. Whether it is the amount of the reactant reacted after time t or the amount of the reactant remaining at time t. So always remember, for the first order reaction, it is a log A by A minus X, where A is the initial concentration, X is the amount reacted up to time t. So A minus X is the quantity remaining at the time t. So this time is equal to 2.303 by K. So this will become into log 102. Log 102. So it is 2 times. Times equal to 4.606 by K. This is the answer. 4.606 by K. For a first order reaction, the rate constant K is 2.303 into 10 power minus 3 per second. What is the time required for 40 gram of the reactant to become 10 gram of the reactant? Actually, this reaction can be proceeded like this. K is given. So what is the time required? Means T is equal to 2.303 in by K. It is again 2.303 into 10 power minus 3 into log of initial concentration is 4 and the final concentration is 10. Like this you can do. But the simpler method to do this is, so it is 40 gram. After a half-life, it becomes 20 gram. From here, after another half-life, this becomes 10 gram. So your 40 gram substance to become 10 gram substance, 2 half-lives have passed. So if you could directly find out the half-life and double the half-life is the time required for the reactant to become 10 gram from 40 gram. So what is half-life? Half-life for first order reaction is 0.0693 divided by K. It is 2.303 into 10 power minus 3. It is K. So this half-life is approximately, this becomes 300.91 seconds. So 2 half-lives, 2 into T half is equal to 601.82 second, which is approximately 602 seconds. So for a first order reaction having the rate constant 2.303 into 10 power minus 3 per second, the time required for the reactant to come down to the mass of 10 gram from 40 gram mass, it is 602 seconds. 602 seconds. So the next problem. The rate of a first order reaction is 0.04 mole per liter per second. See, this is the rate of the first order reaction. It is not rate constant. It is the rate at 10th second. And the rate becomes a 0.03 mole per liter per second at 20 seconds. So when time goes on, the rate comes down. What is the half-life period of this reaction? So first you have to find out K. K is equal to 2.303 T2 minus T1 log of A minus X1 by A minus X2. At various times, it has to be substituted because we do not know what is the initial concentration. If you take this as the initial, this is the final, this is the time gap, you can find out. That is what we have actually done. See, this is taken as A0. This is taken as A minus X. This is taken, right? And then the time interval between 10 seconds, that is taken as the time interval. So this is equal to 2.303 divided by 10 seconds log of initial concentration is 0.04, concentration remaining after 10 seconds is 0.03. So if you do this, it is log 4 by 3. So this is log of 4 by 3, which is equal to log of 1.33. If you take the log value and find out, it is 2.303 by 10 into 0.1249. 1249. This is the K value. Rate constant is calculated. It is 2.303 by 10 into 0.1249 per second. Now, what is asked is the T half, the half-life period. Half-life period is the time taken for the reactant to become half of its original value. If 100 molecules are taken, what is the time taken for that to become 50 molecules? So the T half for the first order reaction is 0.693 divided by K. So you can substitute everything. It is 0.693. So divided by 2.303 into 10 divided by 0.1249. So it becomes 24.1 second. So the half-life for this reaction is 24.1 second. Is it clear? So the next. Your reaction is 50% completed. In 2 hours. And the reaction is 75% completed in 4 hours. What is the order of the reaction? Just you have to think and find out. What is the order of the reaction? See, 100 becomes 50. So 50% completed. So from 50% completed in 2 hours. From 50 to 25. So from here, from 100 to 50, a 50% completion. From 50 to 25, another 50% completion. This takes place in another 2 hours. So from 100 to 25. So totally 75% completion in 2 plus 2, 4 hours. So this is possible only when the reaction is first order. Only when the reaction is first order. The next problem is another interesting problem. For a reaction between A and B, A and B giving product, watch closely. Order with respect to A is 2. It is a second order reaction with respect to A. Order with respect to B is 3. It's a third order with respect to the reactant B. Now, the concentrations of A and B, the concentrations of A and B are doubled or